Hi everybody, I'm Jianyuan, coming from Alibaba Cloud. Now I'm going to introduce one of my research work titled A Two-Stage Heavy Hitter Detection System based on CPU spikes, the cloud scale gateway. Now, first look at the background. Alibaba Cloud provides plenty of cloud services. For example, we provide virtual computing services like virtual machines, containers, auto-scaling. We also provide virtual network services like VPC, VIP, Net Gateway, and SLP. We also provide a lot of other cloud services. The similar services are supported by other main cloud vendors. The cloud gateways plays an important role in inbound and outbound traffic for these services. The gateways provide functions like virtual routing, ACL table lookup, counting, metering, in-cap, decap, and load balancing, etc. The gateways can be classified into two categories, software gateway and hardware gateway. The hardware gateways are hardware-based. Platforms such as P4, SmartNIC, FPGA belong to this category. The hardware gateways forward packets at long range. They hardly experience any heavy hitter problem. The software gateways are CPU-based. Platforms such as the VM, container, and host belong to this category. One of the shortcomings of software gateways is that it has a limited baud rate for each core. For example, 1 Mbps. However, a single heavy hitter which exceeds the throughput may cause severe packet drop in one core. While lack of flow scheduling ability between cores due to NIC RS function, the gateways themselves cannot avoid this problem. In this research, we concentrate on heavy hitter detection on multi-core software gateways. There are a lot of previous work for heavy hitter detection. However, this method can only achieve one or two aspects of low overhead, including low computation, low memory, and low storage overhead, leaving them unsuitable in large-scale production environments. In this research work, we propose a heavy hitter detection framework called cloud-centric. Our target is to achieve low performance overhead in all three aspects: low computation, low memory, and low storage. But how to achieve this target? Our method is based on an observation of traffic pattern in production. This figure shows the network traffic and packet drops on NICs, the software gateway cluster in Alibaba Cloud. From this figure, we can see that network traffic is periodic and steady for most of the time, showing the purple line, and the traffic bursts, which are 3 orders of magnitude lower than the packet rate, happen at a very low frequency, showing the green line. One conclude from this figure that it is a big waste to do an always-on, fine-grained heavy hitter detection at a steady traffic period, because heavy hitter happens infrequently. Therefore, Cloud Sentry uses a two-stage heavy hitter detection system. In the first stage, it launches a coarse-grained CPU spike detection program. Once a CPU spike is detected, it triggers the second stage of fine-grained heavy hitter detection program. It is an event trigger heavy hitter detection method. The coarse-grained detection is an always-on detection model. It collects and reports the CPU utilization rate at every second. Once one core exceeds a predefined threshold, for example 90%, it triggers the second fine-grained detection. Compared to packet level monitoring in data plan, the CPU utilization monitoring in control plan is lightweight enough and does not impact the data plan at all. Therefore, they saved a lot of processing resources when network traffic is in normal steady stages. The fine-grained detection is an uneven trigger detection model that captures packets, for example, 100 packets in the core that has spikes, and then extract and aggregate packet tuples to locate which flow, which tenant, and which service is the culprit. After the heavy hitter is detected, a backpressure algorithm can be called to limit the sending rate of the heavy hitter source, usually half the sending rate. In case a long duration of heavy hitter degrades network performance significantly, it provides a fine-grained heavy hitter analysis just when a severe check burst happens. Cloud Sentry has been deployed in Alibaba Cloud globally for over 1 year. In our deployments, it is deployed in a centralized analysis controller, just with a single server, and we run a detection thread for each region. In one representative gateway cluster deployment during 1 month, Cloud Sentry consumes only 2 to 5% CPU utilization rate, takes 8 kilobytes runtime memory, and produces 10 megabytes heavy hitter logs. Cloud Sentry helps cloud vendors to detect and backpressure heavy hitters in just 1 minute. At last, I want to share 3 experiences we learned from deployment. First, a heavy hitter detection method must be low overhead and robustness. We should not spoil the resources for data processing. For example, storage, database, stream computing are unlimited. It is a big waste for storing and processing big fine-grained raw data. We also learned that using cloud components help improve the system robustness. Second, most CPU spikes are caused by one dominant tenant. We call this dominant tenant effect. Therefore, finding the dominant tenant is very important in cloud heavy hitter detection. Third, the impact of persistent heavy hitter is larger than transient heavy hitter because one persistent heavy hitter event may cause thousands of tenants suffering from the degradation of network performance, and the tenants are sharing the underlying network resources. Okay, this ends my presentation. Any valuable questions will be appreciated. Thank you.